Friends and viewers, very good morning to you all, and I extend a hearty welcome to my YouTube channel. Myself, Dr. M.H. Annaya, and friends, in today's video, we are going to learn about the development of the lateral surface of a cone, which is cut by a section plane which is normal to VP, such that it is passing through the apex of the solid. So, as usual, in the first step, we are going to place the cone on HP such that when seen from the top, it is seen as a circle in the top view and as a triangle in the front view. So let me mark XY and draw the circle of the given diameter. Here the diameter given is 50 mm, and this is the top view of the circle, and this circle I am going to divide into 8 equal parts. This division is to be done because the cone and cylinders have no edges or they have no corners. So this is how I have divided into 8 equal parts, and this has got a dimension of 50 mm. I will show it as 550. 5 means the diameter is 50 mm. And let me number these as A, B, C, D. A, this is B, this is C, D, E, F, G, and this point is H. O is the apex, and from here let us produce all these points onto the XY line. We get here center of the base. From there let us write down the height, which is 80 millimeter, and I will show that height, and this point is O dash, the apex. The height of the solid is 80 mm that I am marking, and I am going to join this O dash to this point A dash. I am going to join O dash to A dash, O dash to this point, this is E dash, this is C dash, G dash. Here you get F and D, so I will call it as F dash comma D dash. This point is B and H, they fall on the same line. So this I will call it as B dash and H dash, B dash comma H dash. And let us join all these generators to the apex. So I have joined all these. Friends, this is the axis which is perpendicular to HP. This is how we obtain the front view and top view of the cone resting on its base. Next, after this, let us see the section plane. The section plane is normal to VP, inclined to HP at an angle 70 while passing through the apex. Friends, this is the apex O. I will write a line through that apex and inclined at an angle of 70 degrees to HP. So this section plane is seen as a line here, line SS, which is inclined at an angle of 70 degrees to HP, 70. And this section plane, friends, is passing through O, and it is not cutting any of the 8 generators, OA, OB, etc. And it is passing through the base. It is cutting the base represented by this. Where all it is cutting? From this point where it is cutting the base, write a vertical line. So it is cutting here on HG and also on BC. These are the 2 points. So totally there are 3 points in the development. One is the apex, second is 2 points on the base. So only 3 points you are going to get in the development. Friends, to obtain the development, we have to calculate theta. Theta is the sector angle, which is R by R into 360. Here R is equal to diameter by 2, base diameter 50, so 50 by 2, that is 25 mm. And friends, you have the other parameters like this capital R. This R is the length of the slant generator, that is nothing but O dash E dash, that is also equal to O dash A dash, which can be measured using a scale after construction of the front view. So you will be able to calculate what is theta from these two. Say we get some angle, and this angle is to be calculated using a calculator. Now friends, after the section plane cuts the solid, let us say this part of the solid is retained, the larger part preferably. This is the part which I have shown in color lines, is the part that is retained. We will call this as P. P is this right side half. So that is B. P will call. And friends, how to draw the development? So we have calculated theta, and here I am going to write two lines which are at an angle of, this is O, this angle is theta, which you have calculated already. Now this sector is to be divided into the number of parts this circle is divided. So there are 8 points on this. So I am going to divide this sector into 8 equal parts. So 2, and this is 2, 4. Again in between we'll have one more line, second, third, and fourth. So this line represents the base. So how to start the development from? Before that we should know this is your R, and this is also R, which is obtained from the front view. We know that value. Friends, there should be vertex should be retained in this part. So here O is one of the points through which the suction plane is passing. Then friends, here when you see the front view, the slant edges O dash A dash, O dash B dash, O dash H dash are removed. And hence you can start the development from A. Then comes B. This is C, D, E, F, G, H, and again A. You got one point already. We need to obtain 2 points. That is where the section plane is cutting the base. It is on HG, say almost at the center. On HG in the base, we will get a point here. And friends, it is also cutting BC. So you can just measure the distance, they will be same. Mark that. So we will call this apex as 0.1, this as 0.2, and this as 0.3. See friends, here I will join 1 to 2, 2 to 3 to obtain. That is 1 to 2, 1 to 3. We will join this one line, second line, and this part of the base is also retained. So these points are 1 here, 1 at the vertex, 2 and 3. 2 is on BC. This is 2 and this point is 3. And the portion that is retained here should also be shown by a dark line till here. This part is P from here to this one. So friends, this is the development of this part P, which is cut by a section plane, and the figure 0 or 1, 2, 3, 1 will give you the development of the larger part of the cone, that is part P, when it is cut by the section plane inclined to HP and normal to VP. Friends, I hope that the presentation was interesting, and if you find this useful to you, do share the information with all the friends and have a blessed day. Thank you very much.